Today we're going to start talking about congruent triangles. Our vocabulary for today is corresponding angles, corresponding sides, and congruent polygons. Geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Two polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. When you look at a congruent polygon, we can see the diagram on the left. Triangle ABC is congruent to triangle DEF, which means that A is congruent to D, B is congruent to E, and C is congruent to F, as well as the corresponding sides. Notice that the order is very important. You could not say that A is congruent to E because A is first in the naming of the triangle and E is second in the naming of the triangle. The two first letters are the congruent angles, the two second letters are congruent, and the two third letters are congruent. It's very important that when you name your triangle, you name it in the correct order. Similarly, you see below polygon PQRS is congruent to polygon WXYZ. Notice we started in the upper left for the one and in the upper right for the second one. That's because if you were to turn or rotate 90 degrees, then the W would be in the same position as the P and you would be able to see them both as congruent. Two vertices that are the endpoints of a side are called consecutive vertices. For example, P and Q are consecutive vertices. To name a polygon, write the vertices in consecutive order. For example, you can name a polygon PQRS or QRSP or SRQP, but not PRQS. In a congruent statement, the order of the vertices indicates the corresponding parts. When you write a statement, such as triangle ABC congruent to triangle DEF, you are also stating which parts are congruent. So here we want to identify all pairs of corresponding congruent parts. So for our angles, we would say P and S are congruent, Q and T are congruent, and R and W are congruent. And then we could also name our sides. PQ to ST, QR to TW, and RPR to WS, or SW. If a polygon LMNP is congruent to polygon EFGH, we want to identify all the pairs of corresponding congruent parts. If we look at the position of the letters, L and E are the first letters, so those angles are congruent. M and F are the second letters, so those angles are congruent. N and G are the third letters, and P and H are the fourth letters, so those are all congruent angles. The sides, we look at the first pair, LM, and that's congruent to the first pair from the other one, EF. MN, the middle two letters, congruent to FG, and NP, congruent to GH, the last two letters, and then the first and last, LP, congruent to EH, the first and last for the other one. Here we're going to use corresponding parts of congruent triangles to go ahead and solve an equation. So if ABC is congruent to DBC, we want to find the value of x. So since BCA, angle BCA, and angle BCD are right angles, we know that angle BCA is congruent to BCD from the right triangle theorem. Measure of BCA is congruent to measure of BCD, and therefore we can plug in two numbers. So 2x minus 16 is equal to 90 degrees. So if we add 16 to both sides, 2x is equal to 106, and dividing by 2, x is equal to 50. Here's another example. We want to find measure of angle DBC. DBC is the one in the bottom corner, and our triangle sum theorem says that measure of angle ABC, plus measure of angle BCA plus the measure of angle A is equal to 180 degrees. And that's using the triangle sum theorem. If we substitute 90 degrees for BCA and 49.3 for angle A, we get this equation. Simplifying by adding 90 and 49.3 together, we get 139.3. And subtracting the 139.3 from both sides, we get the measure of angle ABC is equal to 40.7. If that angle is 40.7, we also know that DBC is congruent to ABC because corresponding angles of congruent triangles are congruent. Therefore, the measures of the angles are congruent, and ABC is also 40.7. Here we have another example where we have triangle ABC congruent to DEF, and we want to find the value of x. Looking at our lines, we see that AB is congruent to DE, those two red lines that I've highlighted. So the measure of AB is equal to the measure of DE. Substituting the values, we get 2x minus 2 equals 6. Add 2 to both sides, and divide by 2 to find that x is equal to 4. Here we're given again that ABC is congruent to DEF, and we want to find the measure of angle F. So we use the triangle sum theorem, and because corresponding angles of congruent triangles are congruent, we know that ABC, which I highlighted there, is congruent to DEF. So that is also, DEF is also going to be 53 degrees. Now if we substitute the 53 and the 90 into the triangle sum theorem, we can see that 53 plus 90 plus measure of angle EFD is equal to 180. 53 plus 90 simplifies to 143, and we subtract 143 from both sides, leaving us with the measure of angle F equal to 37. Here's your lesson quiz. Go ahead and take some time to practice these and see if you have any questions. Make sure if you have any questions that you bring them to class tomorrow before we practice with some further applications.